found another application type of question that I wanted to put into a video format so you're ready for it. So this one is giving you this E function. E is representing the rate at which the water is going into the tank. And what we are looking at is we are integrating its derivative from 3 to 14. So this is actually going to use the fundamental theorem of calculus. So we had a fundamental theorem that said when we integrate something, we get its original value of the top minus the original value of the bottom. So we said that the integral was like f of b minus f of a. Might sound familiar to you. So here's how this is going to show up. So if we are integrating from 3 to 14 e's derivative, we're going to get e of 14 minus e of 3. Top minus bottom. We did that a lot when we found area. We did that a lot with definite integrals. It was called the fundamental theorem of calculus. So this is wanting us to figure out, well, what is that? What is e of 14 minus e of 3? So they actually give you this e equation. So you're going to use your calculator and plug in both 14 and 3 into that. You do not need to use an integration button or a derivative button. You're actually just plugging those numbers into that exact equation. So on my calculator, I'm going to do negative 36 sine of 0.05, and I'm plugging in 14, so times 14 squared, plus 16. So that's going to be your e of 14, minus you want to do e of 3. So minus, I'm just going to put all of it in parentheses just to make sure it's all there, negative 36 sine of 0.05 times 3 squared, because I'm replacing that variable with 3, plus 16. So that's top minus bottom. So I get 28.852. So we'll type that in first, then we'll talk units. And now your units. So I put a comma and not a point. 852. So your units are going to be the units of E, because it was E of 14 minus E of 3. E is in terms of liters per hour. So we are going to stick with liters per hour and get your answer. I think, yep, they actually explain it the exact same way. So you can look up at some of their examples. These are the values that I got from my calculator, and they also talk about the unit. And this is actually similar to one we did in the previous video. So you are integrating this L function on your calculator from 1 to 10. And then you'll notice this 1/9. That means you're doing an average value. So you're getting an average value of this L function. So it will be the depth of snow. So it will be the average depth of snow over that interval. The rest is totally done on the calculator there. We have another average number of people. A lot of average values in these. This one is an integrate to accumulate. We know how fast people are entering a sports arena. So if we integrate from 0 to 25, it will accumulate the number of people that have entered that arena over that 25-minute period. But then you do need to keep in mind that there were already 170 people there when you started. So whatever answer you get on your calculator, you're going to have to add 170 to it. Now notice, since your answer is representing people and you can't have part of a person, they do remind you that we are going to the nearest whole number because you can't have part of a person. I think that is going to give you a really, really good sampling of the types of questions that are asked in this section. Lots of integration again. Every now and then you will get some derivatives when you're talking about maybe finding a rate, but overall lots of integral applications.